Hey, what's going on? You know that you need Linux skills in order to get a DevOps job, right? But Linux is this huge mammoth topic, and the question becomes, where do you begin? So in this video, we're going to actually go through like a pseudo real world problem that's on a Linux server. And doing so, it's going to give me the opportunity to show you like the Linux things that you'll do in a realistic scenario on a routine basis. And I think it'll also make the new Linux stuff for you a little bit more sticky in your brain because you'll see it in the context of actually how you would use that in a real DevOps scenario. So let's jump over here and we'll just dig right into it. Hey, so if you're new to the channel, I am Will. This is DevOps for Developers, and we're going to jump right into this. So here's the problem that we've got. We've got this website, demo.devopsfordevelopers.io. Should be working, and it's not. So the very first thing we've got to do is figure out how to learn something about this system. So now it's running in AWS. So we pull it up in the AWS console. So this is not an AWS tutorial, but we are launching our instance from AWS, and there's a little bit of info that we need here. For example, we've got to connect to it, right? We can't do any troubleshooting if we can't connect to it, and we're going to connect to it via SSH. Now, I've got a private IP address here and a public DNS name, a public IP address here. All of those are different things that you may need to know. So here's one thing I did not set up for this demo for you. Ideally, you're only going to connect to this private IP address, right? Because we're going to SSH into it. You don't want that SSH port, which is TCP port 22. You don't want that exposed to the public because you'll just have little script kiddies banging on that all day, all night long until they succeed in gaining access. It's up and running on this server just for the purpose of this video right now. So hashtag disclaimer there, right? Normally what you do is say, okay, that's a private IP address and I need a VPN connection into this AWS VPC, and that's how I'm going to get access to this server. I don't have that set up right at the moment. So we're going to use, we can either use the public IP address here, or we can copy the DNS record here. DNS being just a human readable name for an IP address. So let's do that. So we'll do SSH. I know it's an Amazon Linux system. That's important to know. I know because I built it. You may not know that. That could influence the username that you type in here. So with my SSH command, I'm typing in my username of EC2 user, trying to hit the @ symbol, but those are the wrong keyboard strokes. And then we'll paste in the name here. So now if, here's another thing that's not set up for this demo, because this demo is just for this video for you and for me. If this were an Ubuntu system, the username would be Ubuntu, or possibly admin. I don't really work with Ubuntu a whole lot. But the TLDR there is the username can change based on the specific distribution that you're running. Now, in long-lived Linux systems, you'll have your own username there, right? And actually, let's just go do that. So let's SSH in here, and I get permission denied, right? Well, why on earth would that happen? And it's because by default, SSH will use your default SSH key, right? Which usually is named like ID_RSA. Now this system was built with a different key. So we'll go and tell it, use the -I flag, and then the tilde always tells your bash or your shell interpreter to look in your home directory in the .ssh folder, and then I think this key is called willbutton_AWS. We're going to find out. There we go, and we're in. Okay, so now we're in as the EC2 user. Ideally, what you want is you want a user account for every person who is logging in to your server. You don't want people sharing credentials, right? So we can do that with the user add command. Also need sudo or sudo, however you want to say it there. And so sudo is something that you'll probably use a lot because you need elevated permissions in order to access system level stuff in there. So sudo is actually sort of an acronym. It stands for super user do. So super user do this. Whatever comes after that command is what the super user is going to do, right? So just to go off on a tangent here, who's the super user? Well, it's root. So if we cat the etc password file and we go up here, there's always a user called user with the user ID of 0 called root. That is your super user in Linux. So whenever you say sudo do something, you are taking the permissions of this super user account, and whatever command you pass to it will be done with those permissions. So we'll do this with our sudo user add command and then -m to create our home directory. Give it the username. And so now if we actually do our password file again, then you can see this new user has been created here. And oh, look at that. Looks like I've been in here before. Good thing I'm consistent, right? So now we could log in with that user. And then in order to do that though, so we created the home directory for it. So if we look in home, will button, and so that directory doesn't belong to me, right? So again, we'll do sudo, and there's nothing in there, right? But in order to SSH in with your key, you need to have this file called authorized keys, right? We can actually cat this out. And this is for the EC2 user that I'm logged in. In order to log in as will button, we would have to create this file on there. But what you can see here is this is my public key for my SSH keys, right? And so the key thing here is this is my public key, not my private key. And if you're not familiar with SSH, check out the video that I have on SSH keys and how you use them and the difference between public and private keys, which is implied in their name, but it's easy to get mixed up. I've mixed them up before. I'm sure you'll mix them up at some point. Watch the video, check it out. But meanwhile, our website's still not up because I'm rambling here. So let's go over here. I think the first thing I want to do is do the old sudo netstat -plnt. So netstat listens for to see what ports are open, and then the plnt flags will give us some different output. Yeah, I cannot talk and type at the same time. So the P here gives us the process ID or PID name that's associated with that port. I can't remember what L and N are for, but the T is for TCP. So we're trying to troubleshoot our website here. So we know that it's going to be on TCP port 80 or TCP port 443. So we put the T in our command because we only care about TCP ports. And so now let's check this out here, because we can see right here we've got port 111 open, port 22, which is our SSH port, that is open. Port 25, which is for mail, is open on localhost. And then 111 and 22, again, are open on TCP, but this time is the IPv6 settings. So either way, nothing is listening on port 80 here, or 443, but for the purposes of this demo, we're only interested in port 80, which is your HTTP port. HTTPS, secure HTTP, goes over port 443. So we don't have anything listening here, meaning our web server's not running. All right, so what do we want to do from here? Let's do sudo systemctl status nginx. Nginx. Yeah, that's spelled right. Okay, can't be found. Maybe it's running Apache. Nope. Or maybe it's called Apache 2. No, that's for Debian and Ubuntu. This is a Red Hat based distribution, so it's going to be HTTPD, but that's not found either. All right, so that's kind of where we're at. It's starting to look like the port is not open because we don't have a web server at all, which makes sense, right? So let's do this. We don't see the service in there, but let's take a look at the etc directory, and that flew by really quick, so let me do that again for you. We're going to look at the etc directory, as in etc. And because what you'll find in there is this is where you find the configuration files for all of the things that are configured on this. And that scrolled past the page here. So one of the things we can do in Linux is we can pipe one command into another, right? So here I'm saying take the output of the command ls/etc, and we're going to pipe that to another command called less, which is a pager, right? So now we've got this nice little output here, one line at a time, and I can use my Vim style binding, so I can use J to go down one line at a time, or K to go up one line at a time. I can use page up, page down, and then I can also use the letter U to go up one page, the letter D to go down one page. But we're looking here for something that looks like it might be a web server, nginx, just to see if there's a config here. We know that the service doesn't appear to exist. Hoping there might be something in configuration here, and we're down at the end and there's nothing. So, all right, I'm gonna hit the Q to exit the less pager, and we don't have a website installed. All right. Let's install one. So we'll do sudo yum install nginx. Nothing to do. Also, the package isn't called nginx. Nginx is available in the Amazon Linux extra topic. All right. Well, let's just paste that in there. Run that. And so now what that's saying is on Linux you have different package repositories to get your software from. Let me hit yes here real quick. So a repository is kind of like a GitHub repo, except it has a list of packages available for your specific distribution, right? Because something that's compiled for Debian is not going to work on something that's compiled for Red Hat or something that's running Red Hat, right? So you have these different distributions or different repositories based on your specific distribution of Linux. And every installation you do will come with its own repositories for that OS distribution, but then you can add other ones as well. Now this is something that's cool to know. Whenever we install something without adding another repository to our system, we're going to get the repository maintained by that distribution. For example, if we are running on a Debian system, we're going to get the repository that's maintained by the Debian maintainers. If we're running a Red Hat based distribution, we'll get the repository maintained by the Red Hat maintainers. And I will promise you that's probably not the latest version of that application that's available, right? Because here's the way it works. Just sticking with our Nginx example here, Nginx developers will release a new version. They'll put it out on their website, push it out through their channels. Then that will notify the package maintainers at Red Hat and Debian and all the other distributions, and they'll go, cool, let's see if we're going to update that. And then they'll test it and go through their whole vetting process. And then once they're ready, they will add that version to their repositories, right? But that takes a lot of time because, you know, those guys, the open source maintainers, have a lot of work to do. So there's a little bit of a time lag there. But the other thing is they go through this really extensive testing process. So anything that I install from the Red Hat or the Debian repositories is like all but guaranteed to work on this distribution because they've gone through and they've tested everything to make sure that it's going to work. And like that's their stamp of approval, is putting it in their repository. But if I wanted something a little more current than that, like if I wanted the latest version of Nginx, Nginx might have a Red Hat based repository that they host that I can add to my system and then get the latest version of Red Hat. But doing so, the responsibility of making sure that that works with my specific distribution is now on me. All right, that's enough of a rant. So it looks like Nginx was installed here. So let's do sudo systemctl status Nginx. All right, status is loaded and it is inactive, meaning dead, because we've never started it. So let's fix that. Instead of status, we'll do start. Oh, look at that. That was some thrilling feedback. So let's see what the status is now. So now our status is active and running. By the way, I don't think I've explained this yet. System control is the systemd command for monitoring and start managing systemd type services. And we'll probably come back to that. As a matter of fact, you can see the service target that was loaded here came from user lib systemd system nginx.service. Active and running, we saw that. This is when it was started 7 seconds ago. And then we get some process information here. The master process, the worker process, because Nginx uses worker threads. And then we get a few lines from our logs here. All right, so looks good. One thing that's good to know here, at some point I'm going to reboot this system. When I do, I want Nginx to come back up. So systemctl enable Nginx. So now whenever the system reboots, Nginx is going to restart automatically. Notice this, it created a symlink from etc systemd system multiuser.target.wants Nginx service to the Nginx service. And so that's just getting into systemd and how that works, which is a whole nother video. All right, so we think it's up and running. Let's do netstat-plnt. And the order of the letters there, PLNT, doesn't really matter. I'm OCD. Actually, the reason I do that is because it spells plant. Well, it almost spells plant, but that just helps me remember it. Anyway, so if we look over here, bound on port 80 on our IPv4, it's bound to 0.0.0.0. That means it is bound to every Ethernet interface on this system, right? It could be bound if we had multiple network interfaces on this system. We could bind this to a single interface, or if we only wanted this to operate within the system itself, like nobody outside could get to it, we could bind it to localhost, which is 127.0.0.1. But that looks pretty good, right? So we can actually use our curl command here and do curl localhost port 80. And look at that. I mean, it looks cool. If you can parse HTML in your head, you know, it looks like a beautiful website. Let's jump over here though and do something a little different. hit the old reload, and boom, we have a website. Okay, so as cool as this website is, it's actually the wrong content, right? That's not the website that's supposed to be displayed. So I actually happen to have the correct content. Let's get out of here. So I closed my SSH connection. I am on my local workstation now, and in here we see the index file that, or the website file that should be loading on this page. The problem now is I've got to get this up to my, my remote server there. So the way we can do that is with a program called SCP. Secure copy, that's what it stands for, SCP, because you have the CP command, and then we have SCP, secure copy, which secure copy knows how to send files through our SSH connection, right? So we were just logged in through SSH, so we know we have a valid SSH connection. We're going to need to specify the path to my SSH key. So we'll do that, and then we'll do will button AWS. And then SCP format, if I recall correctly, probably going to screw this up. Actually, instead of just screwing it up, let's just look it up. So source and then target, that's the part I needed. scp-i.ssh will AWS, and I said it was source.target. And so our target is going to be ec2-user at this stuff, which is our DNS name. And then we need to tell it where to put that, right? And we want to do that in home/ec2-user, and then we'll give it the same name. I think this part might blow up. We'll find out. Well, there we go. It's done. I did it right from memory. It's beautiful. So a couple things about the SCP command here that are worth pointing out. I use the -i to tell it which of my SSH keys it should use. If I were just copying up a full directory instead of a single file, I could do this and just have it, let's actually go back over here. So I could give it some directory name here, and then I would do a -r for recursive. And so then it would take some supposed to say some directory there, but it would take everything in that directory and upload it to this path. Now this path here is pretty important because it has to be a path that you have the ability to write to as this user, right? Because I'm copying it up there as this user, so it has to be someplace that that user can write to. And that'll make more sense here in just a second. So let's get rid of all of that, and we'll SSH back in there. I'll use the pwd command, print working directory. I'm in home ec2 user, so if we do an ls there is our index file. But, all right, so this is a good point here. I don't want to leave this in my home directory, right? Because home directories are tied to a specific user. This is our system level Nginx process, our web server. You know, in a real world scenario, this is like the thing that all of our hundreds of millions of customers are hitting. I don't want to risk leaving this in somebody's home directory and then remove their account and have our entire website go down, right? So the question then becomes, where do we put that? So if we look at our Linux file system, actually, I don't know if you can see that because that's at the bottom of the screen, so we'll do this again. There's some different places here, right? We've already seen Etsy. That's for configuration files for different applications. We've kind of touched on home briefly. That's the home directories for the user accounts on this system. Media is for mounting CD-ROMs, which is not even really a thing for this cloud-based server. MNT is where you would mount remote file systems. Root is the home directory for the super user. Boot contains your kernel. Bin is binaries. Lib and lib64 are the libraries for the files that live in bin and sbin. Run's where you'll find some like runtime, specific runtime information for running processes. But let's get to the point here. There's really only two places we can put this: user and var. All right. Those are the things where you put stuff that you manage and you control that are system-wide, right? So if we take a look at user, there's a file system or a subdirectory here that looks very similar to the root level. And so usually what happens, what you'll commonly see, is when you install applications on your system, they get installed to /user. And so what that kind of means is like the things that came from your operating system distribution go in the root directories. The third-party packages that get installed tend to live in user, and our website content doesn't really fit in that, right? So if we take a look at var, short abbreviation for variable, which our website content might be variable, you'll see some different files here. You'll see stuff for DBs and stuff for caches and Kerberos and mail. So those are all like user data files, right? So that seems like a good place to put our content. Let's look at this. The current content that is currently being served up is in user share nginx HTML, right? So here's the index page that we saw on the website. So I could put my my content in here, but I think what happens, like really positive, what happens here is when I upgrade nginx, if they changed any of these files, it would blow away my website. Again, would not make the marketing people happy when our hundreds of millions of customers all of a sudden started getting the nginx welcome page. So we're back to var. So lsvar, and we'll just make a directory here. I'm going to need sudo permissions for that. Var, and we'll call it www, which you'll probably see on a pretty regular basis in your career. So ls, and with our ls we can do -alh, and that gives us the A shows all files including hidden files. L gives us the long listing, meaning gives us the file permissions, the ownership stuff. And then H is human readable file sizes. So these are tiny files here. Actually, we still in our home directory? We are. Well, these are still really small files here, but as you get in larger files, like it'll start appending kilobytes, megabytes, gigabytes on there so that you can get an idea of how big of a file you're talking about here. Oh, check this out. There's an Ansible directory in my home directory, and that's because this is probably the system that I used in my video on how to manage EC2 instances with Ansible so that you're not having to do all of this stuff manually. So if you're interested in that, I'll put a link up here. I'll put a link down below. Be sure and check that out. How's that for #shameless promotion? All right, so let's move index.html to our var www folder. And I can't because why? Because who owns that folder? Who owns it? I'll show you who owns it. Root owns it. So what do? Hey, we sudo that shit, all right? So now, if we go over here, there's our file. But Nginx doesn't know anything about it, right? And I said that configuration data lives in /etc. So let's look in /etc. And we've now got an Nginx folder there, which we didn't at the start of this ungodly long video that's getting longer and longer. And we do have a file called Nginx conf there. That's this file here. Now, the nice thing about files that live in etc is some of them can be modified, right? Nginx.conf is one of those that you can modify. So let's do this. And here's why I say you can modify some of them. Because look at this, there's this include statement right up here. So if you were adding a module here, it's going to look so instead of modifying the modules that get installed with Nginx, you could add your own module configuration to the modules directory and it'll get picked up automatically, right? That's why I say that. So let's take a look down through here. I'm using Vim, by the way, VIM for my editor here. If you're not familiar with Vim, you're going to want to spend some time learning how to use Vim, just because it's not the most intuitive program in the world, but you're going to need it over and over and over again throughout your career. Meanwhile, in our server configuration block here, look at this, we're listening on port 80 and listening on IPv6, and then we've got our root here, which is telling us where to find its contents. So if I do Shift $, that takes me to the end of the line. If I hit I, that puts Vim in edit mode, and then I can do Control W to erase one word at a time. And then we put our stuff in var www. And then all good web servers know if they're given a folder path to look for a file name called index.htm or index.html. And there's a few others in that list too, but we don't have to specify our file name here. So I got out of insert mode, and then I can do a write and a quit. And so now we changed our path, right? Let's go back over here. The page is reloading, but that's still not our content. Why? Because we need to do a sudo systemctl. I think there's a reload command for Nginx. Well, it certainly didn't seem to bitch about that, did it? And there we go. Our content loaded. It's the totally badass website from DevOps for developers. Sweet, dude. Real sweet. All right, so last thing I'm going to show you here. I guessed that there was a reload command, right? That's probably not cool because that doesn't help you because you didn't know that. So how did I know that? Let's do status. And we loaded this thing called a service file here. So I copied that. And I think I need sudo for this. Let's edit that out. And so this is our service target for the Nginx service, right? So there's a bunch of stuff in here. The thing that we're going to focus on here is there was the exec start, which is how we started it, and then reload. This is where the reload came from, and you can see whenever you type reload that it actually runs user sbin nginx -s reload. So if there were other commands available, they would be listed here as well. All right, so there you go. I'm going to cut this video off here. We solved our problem, right? We solved it. The website is now up and running. And hopefully along the way, you picked up a few things about the common things you'll do in Linux on a regular basis, learned a little something along the way. And if you want to go further into Linux, which I'm sure you do, but you kind of like want like the structured approach to it, I do have another video on Linux that covers the Linux questions you're possibly going to be asked during a DevOps interview, which might be a great place for you to start working on building your Linux skills at. Because, for me, that's like the key thing there is I need a reason why. I need something to make the thing that I'm learning stick in my brain. I need something to associate it to. So if you can associate this to a job interview, it's kind of scenario based in that video. So I will put a link to interviewing for DevOps jobs, Linux interview skills here on the screen and down below. Thanks for watching, and I'll see y'all in the next video.